Hello guys, today I will teach you about Java Basic, Part 1. Today's lecture will be theoretical, and you can feel boring, but these topics are very important to understanding Java. So, let's start. First I will talk about what is Java. Java is a high-level, class-based, as well as object-oriented programming language. It is also known as a general-purpose language, which means it is designed to let programmers and developers compile Java code that can run on all platforms that are supported by Java without recompiling. Java applications are normally compiled to bytecode, which can be run on any Java virtual machine, also known as JVM. The syntax of Java is similar to C or C++, though Java has fewer low-level facilities than these languages. The Java runtime also provides some dynamic capabilities, for example reflection and code modification, which are typically not available in traditional compiled languages. According to the report of 2019, Java was one of the most popular programming languages in use according to GitHub, particularly for a client-server web application, with approximately 9 million developers. But what about the Java terminologies? Here comes our first point, which is Java Virtual Machine, also known as JVM. There are 3 execution phases of a program. They are written, compile, and run the program. Writing a program is completed by a Java programmer such as you and me. The compilation is completed by the JAVAC compiler, which may be a primary Java compiler included within the Java development kit. It takes the Java program as input and generates bytecode as output. In the running phase of a program, JVM executes the bytecode generated by the compiler. Now, we understood that the function of Java Virtual Machine is to execute the bytecode produced by the compiler. Each operating system has a different JVM, but the result they produce after running the bytecode is the same on all operating systems. This is why Java is known as a platform-independent language. Our second point is bytecode. As mentioned, the JDK's JAVAC compiler compiles Java source code into bytecode so that it can be executed by the JVM. It is saved as a class file by the compiler. To view the bytecode, a disassembler like Java is often used. Our third terminology is Java Development Kit, which is also referred to as JDK. While we were using the term JDK, we study bytecode and JVM. So, because the name suggests, it's an entire Java development kit that has everything, including compiler, Java runtime environment, Java debuggers, Java docs, etc. for the program to execute in Java. We'd like to put JDK on our computer so as to make, compile, and run the Java program. The JDK includes the JRE, which is our fourth terminology. Installing the JRE on our computer allows the Java program to run. However, we cannot compile it. The JRE includes the browser, the JVM, applet support, and plugins. To run a Java program, the computer needs a JRE. Our fourth point is garbage collectors. In Java, programmers cannot discard objects. To remove or recall this memory, the JVM has a program called Garbage Collector. The Garbage Collector can remember objects that are not referenced. Therefore, Java makes a programmer's life easier by managing memory management. However, programmers should be careful with their code if they use objects that have been in use for a long time, because garbage cannot reclaim memory from referenced objects. Our last terminology is classpath. Classpath is the file path where the Java runtime and the Java compiler look for class files to load. By default, JDK provides many libraries. If you want to include external libraries, they must be added to the class path. So, what about the main or primary features of Java? Number 1. Java is platform independent. The compiler converts the ASCII text file to bytecode, then the JVM executes the bytecode generated by the compiler. This bytecode can run on any platform, be it Windows, Linux, or MacOS, which suggests if we compile a program on Windows, then we will run it on Linux and the other way around. Each OS features a different JVM, but the output produced by all the OS is the same after the execution of bytecode. That's why we call Java a platform-independent language. Number 2. Java is an object-oriented programming language. Organizing the program in terms of the collection of objects may be a way of object-oriented programming, each of which represents an instance of the category. The 4 main concepts of object-oriented programming are abstraction, encapsulation, inheritance, polymorphism. We will talk about abstraction, encapsulation, inheritance, and polymorphism later. Number 3. Java is simple. Java is one of the straightforward languages because it doesn't have complex features like pointers, operator overloading, multiple inheritances, and explicit memory allocation. Number 4. Java is robust. Java language is strong, meaning reliable. It's developed in such how that it puts tons of effort into checking errors as early as possible. That's why the Java compiler is in a position to detect even those errors that aren't easy to detect by another programming language. The most features of Java that make it robust are garbage pickup, exception handling, and memory allocation. Number 5. Java is secure. In Java, we don't have pointers, so we cannot access out-of-bound arrays. It shows array index out of bound exception if we attempt to do so. That's why several security flaws like stack corruption or buffer overflow are impossible to take advantage of in Java. Number 6. Java is distributed. We will create distributed applications using the Java programming language. Remote method invocation and enterprise Java beans are used for creating distributed applications in Java. The Java programs are often easily distributed on one or more systems that are connected to every other through an online connection. Number 7. Java is multi-threading. Java supports multithreading. It's a Java feature that permits the multiprogramming of two or more parts of a program for max utilization of the CPU. Number 8. Java is portable. As we all know, Java code written on one machine is often run on another machine. The platform-independent feature of Java, during which its platform-independent bytecode is often taken to any platform for execution, makes Java portable. Number 9. Java provides high performance. Java architecture is defined in such how that it reduces overhead during the runtime, and at a while. Java uses just-in-time compiler, where the compiler compiles code on demand basics, where it only compiles those methods that are called, making applications to execute faster. Number 10. Java has dynamic flexibility. Java, being completely object-oriented, gives us the pliability to feature classes, new methods to existing classes, and even create new classes through subclasses. Java even supports functions written in other languages like C and C++, which are mentioned as native methods. Number 11. Java has sandbox execution. Java programs run during a separate space that permits users to execute their applications without affecting the underlying system, with help of a bytecode verifier. Bytecode verifier also provides additional security, as its role is to see the code for any violation access. Number 12. Java has a special feature to write once run anywhere. As discussed above, Java application generates a class file which corresponds to our applications, but contains code in binary format. It provides ease-to architecture neutral ease, as bytecode isn't hooked into any machine architecture. It's the first reason Java is employed within the enterprising industry globally worldwide. Number 13. Java has a power of compilation and interpretation. Most languages are designed with purpose, either they've compiled language or they're interpreted language. But Java integrates a rising enormous power, as the Java compiler compiles the ASCII text file to bytecode, and JVM executes this bytecode to machine OS-dependent executable code. This is for today. I hope you have understood the Java introduction, terminology, and main features. Thanks for watching, and subscribe my channel for future videos.